talked about parallelograms. We've talked about rectangles. We had homework on each. So parallelograms, basically everything that a parallelogram is, a rectangle is, with some extra pieces. The extra pieces were for right angles, and that the diagonals were all congruent. Well, that was in this direction. Now we're going in the other direction. So still same thing, all the properties of a parallelogram still exist, and we're going to drop them into a rhombus, but just the things that had a rectangle are not going to go into a rhombus. So a rhombus doesn't have four right angles, and a rhombus does not have diagonals that are congruent, but it has other stuff. So let's look at the other things that it has. And we're also going to talk about a square. I'll come back to this paper when we flip the paper over and go to a square. Okay, so rhombus has four congruent sides. That has not been true so far. So when I put one tick mark, I put it on all of them. So they're all the same, not just the ones across from each other. So this one's 3, 3, 3, 3. That one's 12, 12, 12, 12, and so forth. Okay, we still know that the same things hold true. These are parallel. These are parallel. So that's still true because those are the same properties that got dumped from before. Okay, and let's go ahead and talk about the diagonals. Diagonals still bisect each other. So this diagonal here got split with the other diagonal, but they're not all the same. And you should be able to tell because the rhombus is a little bit slanted. So one diagonal will be longer than the other. So these two are the same. And these two are the same, but not all four. Now that was true in a rectangle. It's not true in a rhombus. Okay, so a rhombus looks basically like a shorter form of a parallelogram is what it is. Okay, now four congruent sides, diagonals are perpendicular. We hadn't seen that before. That means I can draw a box in this corner right here. Now that's going to be important because when we do Pythagorean theorem, we're going to be pulling out a certain triangle. Let me shade it in. Basically, this is the triangle that we're going to be pulling out. One of those chunks there because of the right angle being in that corner. Okay, so that's diagonals bisect. That was the same thing as before. Opposite angles. So that's the different part. So these diagonals have split these angles. We hadn't had that before. So for example, if this angle was 80 degrees, they're each 40. If this angle over here, and remember these are different, they're not the same. So I'm putting double loops on these. So if this one over here was, let's say, 60 degrees, they each be 30. So they're getting split. So again, we're putting the information on there if you'd like. There is the picture of kind of what I added. And remember, I'm going to let you keep this out when you have your test. So that's why we're kind of writing into it in case you want to like add anything in. You can feel welcome to do so. I just think having this paper is a great tool instead of having to, search through all of your notes. You can just look, oh, okay, what was true about a rectangle, parallelogram, and so forth. We'll come back to it because we are doing squares also today. So these are the notes that you should be on. Okay, and remember, write everything that I write down because you don't know what's going to show up on the homework quiz, and I could be pulling from notes as well. Even though it's called a homework quiz, I might pull from the notes as well. Okay, so today's date, since I'm assuming this will only be applied to my Monday classes, this would be the 15th. Obviously, if you're watching it and you're in one of the other classes, do it on the period that the date that you're watching it, obviously, and put the period that you have. Okay. Assuming that this is only going to be used in 8th period, I'm going to put 8th, but I am going to put in parentheses 3rd and 5th as well, because I might possibly have to show this to 5th period since I do have a doctor's appointment if I'm not done by the time 12:30 rolls around, I'll have to kind of stop and show the video. Okay, put your name, and then again, the topics that we're doing is quadrilaterals. Okay, so opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. All of these are the things that a parallelogram is, and a rhombus is those things, plus the three things that we discussed. It's going to have 4 congruent sides, so all the sides are the same. It's also going to have diagonals that are perpendicular. And you can write out the word perpendicular. You can put the symbol for perpendicular. Since those at home probably can't put that symbol down, I'm going to go ahead and write it down. But this is the symbol for perpendicular, so it's an upside down T. The other thing was diagonals bisect opposite angles. Okay, write those down. Again, writing it down, seeing it, reading it makes it to where maybe you memorize it a little bit better. So whenever our test rolls around, it's a little bit easier to use. Okay, we're going to start with, and if you need to, pause the video, but we're going to start with number 1. Okay, so number 1, we have JK is 12, so I'm going to look for it. I'm going to put it there. JN on the inside right here is 7. Okay, that's all they've given us. That's it. Now, using that, I'm going to fill in everything that I can. Well, a rhombus, all sides are the same. So I have just been given every single thing. In a rhombus, just like in a parallelogram, if this is 7, the other side is 7. So I've been given that. Okay, let's see if that's enough, if there's anything else that's missing. So JM is this side, that would be 12. JL, the whole thing, would be 14, because 7 and 7. MN would be the other side, don't know it yet. MK would be the whole thing, don't know it yet. So there's obviously something that I'm missing. If you remember, I told you that this was going to come into play, number 2, for the type of triangle that we're going to have to pull out. Okay, if you listened when we were drawing the picture, I put a little box here. Diagonals are perpendicular, so I can put a box in that corner now. And that means I can pull out any of the 4 triangles. So imagine that I'm pulling out like this top one here. Just going to pull it out and start doing my work. So on this one, I'll kind of pull out the whole thing so you can kind of see it. So this is the triangle that I'm pulling out. Now that I have that triangle pulled out, I hopefully can see the Pythagorean theorem is 7 squared plus, this is my question mark, so I'm going to find this piece here. That's going to be b squared is equal to 12 squared. So we already did this math before in the other one, so it should be easier to do. 7 squared is going to be 49 plus b squared is equal to 12 squared is 144. Subtract 49. B squared is equal to, so it's going to be 144 minus 49. It's going to be 14 minus 9. It's going to be 5, 13, 95. Okay, then I square root it. B is equal to, so I need to find the square root of 95. I'm going to bring my calculator with me. Or my phone. Well, give me just 1 second to get the calculator. So we're not stuck on this. Okay.
Here.
Were you scared?
Go on.
Yes, baby. I'm right here. Okay, so I'm back. Sorry. Obviously, we could do these by hand, but it would take us forever. So I don't want to do that. Square root of 95 is going to be, so I put it in the calculator. And remember, we want to round this about 1 or 2 places. I'm going to keep it consistent with what I did in the last class and round it to 2 places. So this is going to be 9.75. Okay, so there's my answer for this little piece here. So I'm going to write it inside of the picture, and I'm going to put it also, if I need to, in the blanks. Okay, this is 9.75. The other side is 9.75. So there's 9.75. And then MK is the whole thing. So now you have to realize that you have to take this and you have to double it. So 9.75 times 2. And that's going to be 19.5. Okay, so this is why I said that from this point and from the last class, we didn't want to leave things with square roots because it's hard to find things, you know, in our head with square roots. So we needed to round. So we are rounding these numbers when we get to them. Okay, so now we're going to move on to the next one. Again, I want you to try to do these on your own. If you want to pause it and see what you get and then unpause it and see what I get, that would be awesome. So you don't have to just sit there and copy what I write, but actually practice the problems. So become better note takers. So you could, at this point on number 2, pause the video, try it, see if you can get most of the answers. If you get stuck, unpause it and see what you did get right and what you didn't. Okay, so I'm going to keep going to the next one. I'm going to write in the information they gave me. EF is 23, and DF, the whole thing here, is 40. Okay, so that's what they gave us, that part in green. Now, knowing that this is a rhombus, and how do I know it's a rhombus? Not just because it looks like it, but because I read the instructions and it told you it's a rhombus. So that's how we know that these properties are true. Okay, we know that since it's a rhombus, all the sides are the same. So if that's 23, that's 23. All of them are 23. We know if this is a rhombus, just like a parallelogram, if that's 40, this is 20, this is 20. And then lastly, we learned from our drawing and from what we wrote that diagonals are perpendicular. So we have this little square here, and I can pull any of the 4 squares out. I don't know if you noticed, but all 4 squares have the same exact values. So there's really not a certain one that you have to pull out. Okay, so now that I have my square, I now know that I can set up my problem. This is my a squared, my b squared will be my unknown, and then my hypotenuse is 23. If you haven't caught on, your hypotenuse was 12 over here. Your hypotenuse is 23. Your hypotenuse in these types of shapes will always be the outer number. Okay, so this is going to be 20 squared plus b squared is equal to 23 squared. Looking at it, I think the answer is going to be between 20 and 23 is my guess, because it can't be higher than 23 because that goes over here. So we will see. Okay, so 20 squared is 20 times 20, which is 400, plus b squared is equal to, now I don't know 23 squared, so I'm going to do that one. 23 squared is 529 minus 400. B squared is equal to 129. We take the square root. Kind of ran into it, but that's 129. I think you can tell. B is equal to, and I'm going to take this square root and round it if I need to. Okay, sorry. So second squared, 129. And I get 11. So I was off. I said it was going to be between 20 and 23. It wasn't between 20 and 23. It's going to be 11.36. I just knew it had to be smaller than 23. Okay, so there's my answer for this part right here. And remember, if it's on this side, it's on the other side. So now I'm going to start writing into the blanks what I have. and see if I need anything else. Okay, so GF is on the outside, that's 23. HF is from the inside out, that's 20. GH is from here to here, and it's actually what we just solved for, so that's 11.36. GE is the whole thing, so you're literally going to take 11.36 and either add it to itself or multiply it by 2, however you want to do it. So I'm going to multiply it by 2, and I get 22.72. Okay, so take a second if you need to take a picture of it here. We're going to move on to the next part.
Good.
So this was basically just to kind of go through the steps that we just did. What we did is we took the number that they gave us from the outside. We put it on all of the sides on the outside because a rhombus has congruent sides. After we did that, we took the number they gave us in the middle, if they did give us one, like 40, and we halved it. Or if they gave us like 7, we doubled it. We put it in both. Then obviously on both of these, we were missing one of the diagonals. All we did is we pulled out a triangle, and that's a fancy way of saying we took one of the numbers on the inside, one of the numbers on the outside, and we did Pythagorean theorem. You always want to put the number on the outside of the shape as your hypotenuse. So that's going to be the c squared part. So that's the part after the equal sign. And then finally, we doubled the number that we got because it always asked for the diagonal completely, and that meant we had to double it. Okay, so now we're going to move on to number 3 and see how it changes, if it changes. Again, if you want to try number 3, see how much you can do without me going through the answers, pausing it here, and then unpausing it and seeing what you get, that would be awesome. Okay, so we're now going to write in what they gave us. RT, the whole thing, is 22. US, the whole thing, is 18. Okay, so they gave us both diagonals. 22 means that each of these is 11. 18 means that each of these is 9. Okay, let's write in what we have and see if we can do anything else. So V to T is 9. UV is 11. RS is on the outside. ST is on the outside. These two are the same. So once I find one of them, I have both blanks. So the hint, once again, is going to be determined by knowing that we have this little box here. And since we have that little box, we can pull out a triangle. So it changes the way the triangle's Pythagorean theorem values are put in, because this time we're missing the hypotenuse. So all that means is we've been given a squared and b squared, but we need c squared. Okay, and you could have picked from the top or from the side. Remember, they're all the same, so it doesn't really matter which triangle you pick because the work's going to be the same. So it's going to be 11 squared plus 9 squared is equal to c squared. C squared is going to give you the outer number, which is all of them. Now remember, be careful because they gave you 22 and 18, but those are not the small values. Those are the whole values, and you need these small values. Okay, so 11 squared is 121 plus 81. 9 squared is 81. And now we're going to take and we're going to add 121 plus 81. So 121 plus 81, that gives us 202. Okay, then to get C, we do the square root of 202. So I just kind of moved it over because I like C to be on the other side. Now, usually we leave it this way, but I've told you that we don't want to leave it this way now because we actually want a decimal value. So the square root of 202 will be 14 point, and again, I'm rounding to about 2 places. Okay, so this is 14.21, this one's 14.21, 14.21, 14.21. Every single one is 14.21. So the difference is we do not double this because they wanted one side and they wanted another side, they're exactly the same. So do not make the mistake of doubling it like we did in the other one. Okay, now we're going to move on. We haven't really been dealing with the angles, and now we'll be dealing with the angles, which, to be honest, I find that students struggle more. So let's see if it makes sense. So the last thing we wrote in the description was that diagonals bisect opposite angles. This is just a fancy way of saying we split the angles in half. So if this one's 38, this one's 38. And if you remember from what we learned before, these are alternate interior angles. So if that's 38, this is 38, this is 38. So there, right there, we have angle 3. We have angle 4. And we have angle 5. It's pretty simple if you know that trick. And then lastly, without doing any math, so these is just copying in the numbers, we also know angle 8 because it's the diagonal. Angle 8 is that box we draw, and the box we draw represents 90. So we have all of those without ever having to do any type of calculation. Now, I'm going to try to do some calculations. Well, this still has the properties of a parallelogram, sorry. So remember, this whole thing here is going to be 180 minus, and it's going to be both of these. So it's going to be 38 minus 38. So I'm going to write the math over here so it's not as sloppy. Okay, so that's what I'm doing. That's what I wrote right there, but it was kind of getting kind of sloppy. So now what I'm going to do is I'm going to take my calculator. I'm going to do 180 minus 38 minus 38. Okay, that gives me 104. That is not the answers that go in the blank. 104 is the whole thing. Now, if I know that this is 104, even though they haven't given me one of them to subtract out, since this is a rhombus, and only because this is a rhombus, we can do the following. You're going to take your 104 and you're going to divide it by 2. Now, the reason you do that is because the angles are split. We wrote that in number 3. Diagonals bisect opposite angles. So 104 divided by 2 is 52. So all of these are 52, 52, 52. So now we have actually all of the remaining answers. Angle 1, 52. Angle 2, 52. Down here, angle 6, 52. Angle 7, 52. Okay, no Pythagorean theorem to find them. Pythagorean theorem is only true for sides of a triangle, sides. So when you're finding angles, there should be no Pythagorean theorem. And I think that's the biggest thing, knowing when to do it. Angles, no a squared plus b squared. Over here, yes, because we're dealing with sides. Angles deal with that magic number of 180. And in this case, this shape, we're also dividing by 2 or multiplying by 2. Okay, we're going to do one more before we go into the perfect shape of quadrilaterals, which is a square, because it gets everything dumped in. Okay, again, pause the video if you want, see if you can answer some of these. Now, all of these are sides and all of these are angles. Now, something that I am going to do that I did in my other class, and I think it worked out well, is we're going to redraw the rhombus. And anything that's a side, we're going to do it in the first one. Anything that's an angle, we're going to do in the second one. I think it'll make it to where it's not as messy. And it'll help students maybe see the work a little bit better. So try your best to make the rhombus just exactly the same as the first one. Doesn't have to be perfect, like right there. Mine's a little bit off. This is W, X, Z. V is in the middle. And we also have Y. Okay, I'm going to set that to the side. And now I'm going to write in only the first two because these are sides. This one is going to go into this one. So ZY. This one on the outside is 34. WY, this whole thing is 38. Okay, then over here, I'm going to do 34 degrees is angle ZXY. ZXY, this corner right here. and it's 34. Okay, we'll deal with this shape on the second one. Let's go ahead and deal with this shape first. Okay, first thing I'm gonna do is use what they've given me to fill in what I know. They're all the same, so that's 34. This is 38, so if this is 38, you half it, and when you half 38, you get your two diagonals to be 19 and 19. Okay, so I have that. Now, remember this magic trick that we have, since this is a rhombus, we can pull out this triangle, and this is going to look like the work that we did on the very first two. So my a squared will be, just I think I could do it here. I should have left a little bit more space. 19 squared plus my unknown, so that'll just be b squared is equal to 34 squared. Okay, 19 squared is 361 plus b squared. 34 squared is 1156. Subtract 361 from both sides. Bring b squared down. Okay, minus 361. That gives me 795. Then remember, you still have to square root it and round it to about 2 places. Okay, so my 795, I'm going to square root. And I round this to about 2 places, so 28.20, because it makes it rounded up to 20. Okay, so there's my answer for that one. I'm going to put it here. And I'm also going to put it here, because remember, they're on both. Okay, now that I have that, I'm going to go to my blanks, fill in as much as I can, and see if we're done with that first one. Okay, WZ on the outside is 34, because they're the same. BY on the inside is 19, because we split that number. ZV was what we found when we did this, and that was 28.20. ZX is the whole thing, so you take your 28.20 and you multiply it by 2 because you have to double it, and you get 56.4. So we have all of these sides worked out. That's this right here. Now that I have that, I'm going to concentrate on the angles in just a second. So if you need to pause it, take a picture of that really fast so you can write them in, you can. Or if you want to pause it and try to see if you can get all of the angles, go ahead. Now this one's a little bit trickier because it doesn't have numbers, it has letters. And again, I'll slow down and show you how the letters go, but you have to get better at being able to identify the angle when they just give you letters. Okay, so we're going to move on and we're going to concentrate on angles now. Okay, so for my angles, I know that this is 34. I know that that's 34, this one's 34, this one's 34, and this one's 34. Okay, I know that this corner here is 90 degrees. Okay, so all of them are 90 degrees. I don't know if you caught that, but whenever one corner is 90, all 4 of them are. Okay, so now how do we figure out this big one here? And remember, you do 180 minus 34 minus 34. So I do 180 minus 34 minus 34. That gives me 112. Now that's the whole thing, but I'm going to take my 112 and divide it by 2. So 112 divided by 2 gives me 56. And now I know that each one of these is 56. This one's 56, this one's 56, this one's 56. Okay, we have all of the angles filled in. We're now going to practice being able to get the right number onto the blank. WXZ, WXZ. It dipped back down, so it's the 34. Okay, WV is in the middle, and then Z. So it was actually asking for the middle value, which is 90. ZYW. Z, Y is on the outside. W dips back in, so it's 56. And then the last one, XYW. So it goes down and then it dips back up through the middle. So it's that 56. Okay, write these down. That is it for rhombi. I don't think the work is too hard. If you've been paying attention in the other classes, the only piece of information that's really new is that 90 degrees, and it doesn't make it harder. I don't think it's harder to do the angles. Pythagorean Theorem gets to be pretty simple if you practice it enough. Okay, we're going to move on to squares next. So flip over to the back in just a second. Pause it if you need to so you can get what you need. Now we're going to the last shape that we're going to be learning properties over, and that is a square. The square is the perfect shape of a parallelogram because everything that all of the shapes have is true for a square. It has all of the parallelogram stuff. It has all of the rhombus stuff, all of the rectangle properties. Everything gets dumped into the square. So opposite sides are parallel. Opposite sides are not only parallel, so these are parallel, these are parallel, they're also congruent. So just like in a rhombus, this is all going to be the same. But not only does it have what the rhombus has, it also has what the rectangle has. So all the sides are also 90 degrees. But it doesn't end there. It also tells us, since it's the perfect shape, it tells us the diagonals got bisected. So I'm drawing my diagonals in. Again, they don't have to be perfect. I just grabbed a sticky note to make them a little bit straighter because it is a square and I want it to look nice. Okay, so since it's a diagonal, all of these diagonals are congruent because they got split in half. But since it's a square and a rectangle, they're all the same. So not only do they get split in half, they also are all the same. The next thing is, just like a rhombus, we can put a little box in that corner. So we can still pull out that triangle like we did before. And since we know that all the corners are 90 and they're all getting split, then actually we know that all of these are 45 every time. And I'll tell you why in just a second. Gracias, papito. Okay, well, if they're 90, 90 divided by 2 is 45, and that is going to be true every time because there's no other way to draw a square. Now these, we can switch, we can change the angle size. Rectangles and squares have to have 90 degrees in the corners. Why? Because if not, then they don't follow the properties of what they are. So that's really just about it. We'll see what changes in a square now. Okay. So flip this to the next page. There's nothing to write into a square. We have written everything. Gracias.
It's yellow.
Yellow. You wanna know where yellow is? Go find it. Yeah. Okay. So we don't have to write anything in because everything that all the other shapes have already been written in on all of our previous notes. So it literally is every single property that we have been doing is applied to a square. So the square is the perfect shape, the perfect quadrilateral. It has everything that it needs. Okay, so now let's move on to what can we do with the information they gave us. If quadrilateral A, B, C, D is a square, so they have to tell you that it's a square. Or you can't just assume that these properties are true, okay? So you have to be given that. If quadrilateral ABCD is a square and AD is 11, so they gave you that, find each missing value. Okay, let's see, bless you. Let's see what else we can write in with that 11. This is 11, this is 11, this is 11. Okay, now that we know that, we can put in some information. Well, I just told you that we know that all of these have to be 45. Like that's a given. It's never going to change. If it's a square, Like that will always be true. So you can go ahead and put those angles in. We also know that we can put a box here. So all of these are 90. Okay. Next, we need to figure out probably one of the inside sides. So that's why I put 90 in there, because I'm going to pull out this here, and I'm only going to pull it out on the first one so you can see what I'm doing. And then after that, just like before, I would not, pull out the triangle. I would just go straight to the word. This is the only piece of information that I have. So how am I going to find Pythagorean theorem if I have two missing pieces? Well, here's the thing. Remember, these two pieces are the same. So technically, you're not finding two pieces of information. You're only finding one. So this could be A and this could be A. Like they don't have to have two separate letters. So we're actually finding one letter instead of two unknowns. So it is a little bit different in that aspect, but it's not bad. So what we're going to do now is we're going to go through and see if we can find Pythagorean theorem to get our answer. Okay, so let me see. This is one way we could do it. There is another way. I'm gonna keep it. Yeah. Okay. Oh, you found yellow. Thank you. Thank you. Okay. So here is how it will be set up. A squared plus A squared is equal to 11. This is going to be 2A squared is equal to 11. So I'm going to half this. A squared is equal to half of 11, which is going to be 6.5. No, 5.5, sorry. And then I'm going to square root it. A is equal to, and I'll need to clear this. Okay. Taking the square root of 5.5. And that gives me about 2.35, because remember I'm rounding. Okay, so now that I have that, I can put that into here. 2.35, 2.35, 2.35. All of the inside numbers are 2.35. Oh, I didn't square this. Crap. Just kidding. Let's backtrack a little bit because that number is going to be different. Okay, so this is 11 squared, not 11. So this, I was thinking the number was way too small. This is going to be 121, and then I do 121 divided by 2. And that gives me 60.5. So it's going to change my numbers a little bit. I'm sorry. Okay, now I'm going to take the square root of 60.5, and I'm going to get 7.78. Okay, that looks a little bit better. I'm not going to draw them in here. I'm just going to take this off because it's going to get really sloppy if I try to white it out and put it back in there. So it's going to be 7.78, and then 7.78 can be multiplied by 2, and that's going to give you the whole. So I'm going to go ahead and do that out here to the side. That number would be 15.56. Okay, now that we know that, again, it would get sloppy if I put it back in there. So now I'm just going to fill in the information. Okay, BC is on the outside. That's 11. AC is the whole diagonal. So that's going to be this one, 15.56. BD is the whole diagonal in the other direction. Same thing. Diagonals are the same. EC is one of the diagonals. That was the part we found with Pythagorean theorem. And now I'm going to slow down a little bit so we make sure that we grab the right angles, because a lot of people get confused whenever we're doing these. Okay, DAB. DAB. It's the whole corner. The whole corner is always going to be in a square 90 degrees. E is in the middle, and then B. E is to the middle, and then it goes out. Remember, the middle is also 90 degrees. Okay, C, B, D. It goes up, and then it dips down the middle. CBD is this little corner here, and it's the half. It's 45. BAC did the same thing. Started at B, over to A, dipped down the middle. It's another 45 angle. Okay, so we have that one done. We'll move on to the next one. Hopefully I don't make a mistake on this one, and it's a little bit cleaner. So we know it's a square. They're telling you it's a square, and then now we can put in the information and we'll go from there. Okay, TR is 17. Then it said find each missing value, and that's it. Okay, TR is 17. This is 17. This is 17. This is 17. Okay, this is 90 degrees. This is 45, 45, 45. And at this point, I think in the future, we could leave them off because you know that they're 45. Okay, a little bit less sloppy. Okay, now that we know that, again, we can pull out a triangle, and the triangle is going to look like this. 17 squared plus 17 squared is equal to c squared. This is going to be my side. Okay, so we're looking for one of the sides. Okay, so I'm going to take my calculator and I'm going to do 17 squared. So 289 plus 289 is equal to c squared. 289 plus 289 is going to give me 578 is equal to c squared. Now I'm going to take this and move it to the other side just because I like to have everything on the other side. So 578. C is equal to about 24.04. Okay, now this is the side. All of them are 24.04. This is not a diagonal, so we're not going to split this in half or double it. Okay. Now we're going to write in what we can, and remember when we get to the angles, we'll practice writing in and following the letters. Okay, PR is the whole diagonal, so 17 plus 17, which is 34. QS is the whole thing in the other direction, so it's also 34. QT is only to the middle, so it's 17. And then PQ on the outside would be 24.04. Okay, now we're going to get to the angles. PRS. P, R, and S. It goes down, dips back over. It's 45 degrees. STR. S to the middle and then out. Anything that's in the middle for a rhombus or a square, it will be 90 degrees. PSR. PSR. It's the whole corner. Remember, all squares have 90 degrees in the corners. QPR. QPR goes out to P, goes through the middle, and it's 45 degrees. And there are your answers. Okay. Go ahead and look at them. If you need to, pause the video, write what you need to, and we're going to move on to number 8.
Good.
Okay, so number 8. Now they switch it up. They're telling us it's either a rhombus or a square, so we have to be prepared to be able to use any of the properties they throw at us. Basically, you have to be prepared to know if it's one or the other, and that's how your test is going to be. You kind of have to switch up your brain as to some of the things that you write down. So this one is a rhombus. This one is a rhombus. This one is a square, is a square. So keep that in mind. Okay, so if MNOP is a rhombus, find MP. Okay, here is the thing. We need to find X. We plug back in X, then we have our side, and they're exactly the same on all 4 sides. So that's it. So 9X minus 77 is equal to 3X plus 7. Why do we set them equal to each other? Because all sides in a rhombus are equal to each other. Okay, so we're going to do the math on this one. 9 minus 3 is going to be 6x minus 77 is equal to 7. Add 77 to both sides. Oops. 6x is equal to, this is going to be 84, I believe. And then 84 hopefully divides into 6. I'm thinking it does, yeah. 84 divided by 6 is going to give me 14. Now this is not my answer. My answer is MP. Now MP is any of these sides here. So just pick one to plug it into. So 3 times 14 plus 7. So 3 times 14 plus 7 is going to be 49. Now, does it matter which equation? No, because if you did your math right, then it doesn't matter which one we plug it into. You should get the same answer. That's the thing about it. Okay, so we're done on that one. Okay, this is a rhombus, and it says find FED, and it's an angle. So first I need to figure out where is FED. FED is this angle right here. So if I take this plus this and subtract it from 180, I get my angle, right? I get the value of it. And that's what I want. So this is going to be 180 minus 5x plus 1 plus 8x minus 20. So that's basically what you're going to do in the end. But how are we going to find our x to be able to plug it into that so we can get our answer? Okay, so this is what we will plug in. Now, to plug it in, all you have to do is remember that in a rhombus, these two are the same. So just like we did on the one before, you're going to take your 5x plus 1 and you're going to set it equal to, is that 1? Yeah. Set it equal to 8x minus 20. Once we have our x, I'm going to kind of draw a line here. We can plug it in here, subtract it from 180, and we have our answer. Okay, so first thing I'm going to do is the math here. So minus 5x. 1 is equal to 3x minus 20. Add 20 to both sides. 21 is equal to 3x. Divide by 3. X is equal to 7. I remember that's not my answer, but that tells me what I'm going to plug in here. And once I plug it in, I subtract that number from 180, and that gives me my answer. So angle DEF, or FED, let's write it the way they wrote it so we don't get confused. They wrote it FED. Is equal to, and I'm going to go ahead and do the math here. So first I'm going to plug in 5 times 7 plus 1. That gives me 36. So that should be 36 plus 36. But just to test it out, the next one, 8 times, what's the number, 7 minus 20. That should be another 36. Okay. We take those two and we add them together. So 36 plus 36 gives me 72. So now all I'm doing is 180 minus 72, and that gives me 108. That's my answer. Okay, so we have our answer for it. After that, we're going to move on to 2 square examples. So those were rhombi, plural for rhombus is rhombi. And now we're going to move on to squares. So what if they give us squares and they give us values? Technically, they're worked out very similarly. Orange, yes. Okay, so we'll move on to the next one. So it's a square, and this is what they've given us. SW, right here on the inside, is 2x plus 13. WU, the other side, is 8x minus 41. Find VT, which is the diagonal. Okay, so here is the good thing. These are equal. Why are they equal? Because all of the diagonals are equal. So far, that's all we've had to do. Same style on all of them. Okay, so I have my setup. I'm going to worry about what I need to do to find VT in a second. Okay, so first, subtract 2x. 13 is equal to 6x minus 41. Add 41 to both sides. 54 is equal to 6x. Divide by 6, and x is equal to 9. Okay, so there's my answer for x. Now I need to find out, how am I going to get VT? Well, VT is the whole thing. This whole thing doesn't have any numbers on it, but remember, they all match. So if we can get this value, we have the other side. So all we have to do is plug it into the whole thing. So 2 times 9 plus 13 plus 8 times 9 minus 41. You can also plug it into half of it and then double it. Okay, so you have your calculator. I'll just plug it all in. So 2 times 9 plus 13, that gives me 31. So that's going to be 62. Okay, why is it going to be 62? Because then the other side, 8 times 9 minus 41, also gives me 31, and 31 plus 31 is going to be 62. Okay, so we have our value. Now we're going to move on to the next one. Oh, here you go. It's a square, and all we have to do is solve for x. So they're not going to make us plug it in. We've had to plug it in the others, but not on this one. So usually when they don't make you plug it in, it's more of a complicated one. So let's see how this one looks.
Orange?
I don't know, baby. Where did orange go? Oh, it's right here. Look. Okay. So we have 7x plus 3 on this side. And that's it. So this one does require you to think a little bit. If I said solve for x and this is all I gave you, a few of you would say there's not enough information. You'd give up on it. You would just, leave it there. Yes, the other side is also 7x plus 3, but that still doesn't get us anywhere because you can never set something equal to itself. It's saying like 1 equals 1. If you set this equal to 7x plus 3, it's not going to get you anywhere. So you have to go back and remember what all of the angles are. And the reason I know that this is an angle question is because it has a degree symbol right there. So that's a big hint. And I hope you remember that every single corner is 90 degrees and every single one is split and it's equal to 45 degrees. So now this is equal to 45 degrees. If you didn't have that piece of information in your head, you would be stuck. Pink. Okay, so then we go from there and we're done after that. 7x is equal to 42 divided by 7. X is equal to 6. And all they wanted was x. So we're officially done with the notes. And all I'm going to do now is, I'm not going to tell you the answers, but I'm going to get you to the homework, show it to you, and tell you when this is due again so that this question gets presented. You guys all have the same answer on there. Okay, so pause it if you need to see anything here. And we're going to move on to homework 12. Okay, so again, I'm not going to give you any answers or anything like that. I think all of the ones on here should be fair game. In the other homeworks, we might have had a few that I'm going to make extra credit, but on this one, all of them should be some that you can do. Okay, so this is homework, and when is this due? So I'm assuming that this is 8th period, but this could be 3rd, 5th, or 8th, okay? This due date will be the same for these classes right here. Today that you're watching this video should be the 16th. So this would be due 11/18, which is Wednesday.